All right, in this video I'm going to be going over the practice test for Unit 2. So let's go ahead and get started. So it says here, solve the inequality and graph the inequality. So this is like solving a two-step equation. You can see that we're going to have to add 6 to both sides and divide by -4. In a case like this, we'll always add or subtract first. And so I'm going to go ahead and add 6 to both sides. And when I do that, I'm going to get -4x is less than 36. And so I'm trying to get x by itself, so I need to get rid of that -4. It's -4 times x. The opposite of multiplying by -4 is dividing by -4. So we'll divide by -4 on both sides. And hopefully at this point you're like, oh shoot, I've got to reverse that symbol. I'm dividing by negative. So I'm hoping that's what you're thinking here. And so we're going to end up with x is greater than -9. And we have to graph this. So here's a number line, and we'll just put -9 and 0 on there. And greater than 9, we're going to shade everything to the right of -9. And we're going to use an open circle here. And so the graph looks like that. And so if you were to pick any number in this shaded region and plug it in for x, it would make this inequality true. In other words, there's a whole bunch of answers, every point or every value greater than -9. All right, let's look at number 2. So here we're adding two polynomials. In fact, they're both trinomials, 3 terms. And when we do that, we can just drop the parentheses. In fact, each of these, it's assumed it's 1 times whatever's inside the parentheses, and 1 times anything is itself. And so let's go ahead and drop the parentheses. We get 13 plus 8x squared minus x. And now notice you're going to have a plus minus 5x squared. Let's just write that as minus 5x squared, and then minus 11 minus 3x. And so now we've got some like terms to combine. We can add our 13 and -11 to get 2. We've got 8x squared and a minus 5x squared, and that's 3x squared. And then a minus 1x and a minus 3x is going to give us a minus 4x. Now, normally we don't like to write our final answer this way. This is not in what's called descending order. So we want to rearrange it so that it goes from the highest powers of x down to the constant. Constants always go last. No respect for constants, which in this case would be the 2. All right, on number 3, we've got some simplifying to do. So we're going to go from left to right, and we're going to do our multiplications first, and then we'll end up doing some adding and subtracting of like terms. So 2 times -4, of course, is -8. And then now we need to distribute 5. So 5 times 6 is going to give us plus 30, or positive 30. We'll write plus 30. And 5 times -7x will give us a minus 35x, which we'll write using subtraction. And then don't forget about that 11. You got to bring that down. And so we've got to add -8, 30, and 11. Well, -8 and 30, that's 22. 22 and 11 make 33. And then notice we've got that loner term, the minus 35x. There's no other term I can combine that guy with, so I'm just going to bring it down. And again, this is not in descending order. The constants first. That is not allowed. And so we get -35x plus 33. All right, it's not so much that it's wrong when it's in the opposite order. It's just we normally write our answers in this form here. In fact, we want everybody's answer to look exactly the same. And so we tend to write things in descending order. Okay, so let's look at number 4. We're solving for a. So in this case, we're not really solving and trying to get some kind of number like 3. We're really more rearranging the equation so that it's solved for a different variable. In this case, we want it to be solved for c, and it's currently solved for b. And so sometimes I'll just circle the letter that I'm trying to get by itself, and then I've got to get rid of those other values. Now notice I'm going to have to get rid of the 5a, and since it's 5a times c, I'm going to end up dividing there. And I also have that plus 3 I need to get rid of, and I'm going to have to subtract 3 on that side to get rid of the 3. In a situation like this, we always add or subtract first. So let's subtract 3 on both sides. Now be careful on the left, we have b minus 3. Those are not like terms, and so the only thing I can do is write b minus 3. On the other side, we're going to have 5ac. So again, now we're trying to get c by itself, and we're almost there. We just got to get rid of that 5a. But the 5a is multiplied times c, so we'll do the opposite and divide by 5a. And on the other side, we have to do the same. Remember, we always need to do the same thing to both sides to make things legal. Don't want to break any laws of algebra here. And so you can see on the left, we have b minus 3 over 5a. And on the right, these 5a's are going to cancel, and you're just going to be left with c. Now, I don't know about you, I'm not really thrilled to write my c on the right there. I'd rather put it on the left, but in fact, it really doesn't matter here. Either answer is correct. All right, and if two things are equal, it doesn't matter what side they're on. Let's move on to the next number. So here it says, using the table given, find x if f of x is 2. So we have a function here. We have inputs, or x values, and outputs, which are f of x values. And so we're supposed to find x. Notice x is an input, which would indicate they must have given us the output. Well, the output is 2. So notice these are our outputs. Where do you see a 2? Well, that would be right here. And so x would be 0. Now let me erase the mess I made here. And so x equals 0 is the input value for which the output is 2. In fact, if you said find f of 0, wouldn't you get 2? And so we found the x value that has an output of 2. All right, so let's move on to number 6. It says use the table to find f of negative 2. This time, notice they're giving us the input. That's one of these guys, our x values. And so if negative 2 is my input, what's my output? Well, it would be negative 6. And so we would write f of negative 2 is equal to negative 6. Negative 2 is an input. When you plug it into the f function, you're going to get a corresponding output of negative 6. All right, let's move on to the next slide. So it says, if the range of the function y equals 5x minus 2 is the set with 0 and 2 in it, what is the domain? Well, notice 0 and 2 here, since we're talking about range, these are y values. And so I want to plug them into the equation for y, each one of them, and so I'm going to get 2 x values that are going to be my domain. So I'm going to do the first one over here. We have 0 equals 5x minus 2. I'm trying to get x by itself, so let's add 2 to both sides first. We're going to get 5x equals 2, or 2 equals 5x. Again, I'm trying to get x by itself. I have 5 times x, so I want to divide by 5 on both sides. And so we get 2/5 is equal to x, or x equals 2/5. And so that's the domain, or the domain value when our y value is 0. What if our y value is 2? So let's plug in 2 into the equation. So we're plugging 2 in for y here. And let's solve for x. So I'm going to add 2 again on both sides. And I'll get 5x is equal to 4, or 4 equals 5x. And again, I'm trying to get x by itself, so I have to divide by the 5 there. Since it's 5 times x, I'll do the opposite and divide by 5. And so we're going to end up with x is equal to 4/5. And so remember, these are our two corresponding domain values for the range that we were given. So I'm going to go ahead and write it as the set with 2/5 and 4/5 in it. All right, on number 8, it says, what is the range of the function f of x equals x squared plus 2x minus 4 when the domain is just the set with -5 in it? In other words, there's only one domain value, and that's -5. In other words, -5 is the only number we get to plug into this function, and whatever we get as an output, that's going to be our corresponding range. And so all we need to do here, so notice we've got an x value here, we're talking domain. All we've got to do here is plug that into the function. And so I'm going to make a shell, or what I call skeleton for the function. Wherever there was an x, now there's parentheses. And now I'm going to plug in my -5. And so I'm finding f of -5 by evaluating the right side. So I've got -5 squared. I want to do the exponent first. Of course, -5 times -5 is a positive 25. And then I'm going to have plus 2 times -5. Well, that's going to be -10. So we'll write that as -10. And then let's bring down the -4. 25 minus 10 is 15. And 15 minus 4 will give us 11. And so don't forget, this is the range. And I'm going to write it in braces, just like the -5 was for the domain. So this is our range, the set with just 11 in it. All right, let's look at number 9. It says you are buying cartons of eggs on sale for 50 cents a carton, which is represented by the function f of x is equal to 0.50x. Given that the store only allows you to buy a maximum of 10 cartons at a time, what is the range of this situation? Well, I think it's important to first identify what we're dealing with here in terms of our variables. So first of all, think about what x represents and what f of x represents. All right, so I would say x is the number of cartons of eggs, and f of x is going to be the cost of x cartons of eggs. So really, when it said you are buying cartons of eggs here, that's going to be our x value, the number of cartons that we buy. And if let's say we bought 2, if you plug in 2 here, 2 times 50 cents, that's $1. That's going to tell you the cost of buying those 2 cartons. So we just want to make sure that it makes sense once we've figured out what these variables represent. And so now we need to talk about domain and range. Our final answer is going to be the range. Now it says we're buying cartons of eggs, so I'm going to assume that we're buying at least 1, and I can only buy up to 10. So that makes my domain go from 1 to 10. I'm going to write 1, 2, 1, 2, 3, and I'm getting kind of tired of writing these numbers out, so I'm going to use 3 dots, another comma, and a 10, and that gets me the numbers from 1 to 10. All right, so now think about this. If x is 1, f of 1 would equal 0.50 times 1, or basically 50 cents times the number of cartons, which this is in this case is 1. That's going to be 50 cents. We're saying 1 carton costs 50 cents. If we plug in 2 for the number of cartons, 2 times 50 cents, we're going to pay $1 when we buy 2 cartons. Well, basically we're just adding 50 cents each time. So again, I don't want to do this 10 times. I'm going to put 3 dots and I'm going to find f of 10. It would be 50 cents times 10 since there's 10 cartons. and that's $5. And so basically we're going to go by 50 cents, from 50 cents up to $5. We're going to go by 50 cents intervals. So again, I think when I write the range, I would write 50 cents, $1, $1.50, and then I'm going to do the dot dot thing up to $5. All right, and that's our range. Okay, let's move on to the next slide. So it says here, given the following graph, what are the domain and range? Well, depending on how comfortable you are with the graph, you may just be able to look at the points and write out the domain and range, and that's great. But I'm going to go ahead and write out the points first. And basically, with domain, I'm going from left to right because I'm working along the x-axis. So basically, you can see we've got 1, 2, 3, 4, 5, and 6. Those are our x values. We're not skipping any actually there. So our domain goes from 1 through 6, and we don't miss anything there. Now for the range, that's our y values, and the y-axis is going from the lowest, or from down below, up, vertically. And so I would start from the lowest point and work my way up. So we've got negative, so I'm going to underline my y values, and notice at my lowest point, the y value is negative 1, and then the next point we're at 0, and then the next point we're at 1, then 2, then 3, and then finally at the highest point we're at 6. And so those are just all the y values of my point, the ones that I put in green. And I did it that way because we want to write our numbers in order, although it's not really wrong if the numbers aren't in order, as far as it's still the same set of numbers, but we should write it in order. All right, number 11, the gallons of gas left depends on the miles driven. What does the independent variable represent in this situation? Well, basically it's like you got a full tank of gas, and the farther you drive, that tank's starting to empty out, and you can see it's going down here. The number of gallons is. Now, the independent variable is always found on the x-axis, and that would be the number of miles. It's the gallons that are dependent on the number of miles, not the other way around. But anyway, it's pretty obvious because we know that independent variable will always be on the x-axis. All right, so that is miles. Okay, on number 12, it says find or identify the domain and range of the relation shown in the graph below. Well, for domain, we're going to go from left to right. We want to find the leftmost point, and in fact, we can put a line here, and we can see that there's nothing to the left of this line, and in fact, the x value there is 0. And so our domain, or the lowest value of our domain, is 0. Notice that's a solid point. That point's on the graph. And so we want to include 0 in our domain. And then as you look at all these all these points, x just gets bigger. X is 1 right here. X is 2. And we're hitting all the values of x in between. And we just keep going to the right forever, and we're not missing any of these x values. And it goes forever right, so we would say x is greater or equal to 0, basically. Let me erase this stuff here. So our domain is x is greater or equal to 0. What we're saying is all the points on this graph are going to have values that start at 0, and then they just get bigger without end, and we're hitting every x value on all these points from 0 and greater. Okay, so for the range, since we're moving along the y-axis, we're talking about y values here, we're going to go from the lowest to the highest point, and you can see that we do have a lowest point, and it starts right there when y is 2. So on this graph, the lowest y value is 2, and that point is solid, so this point is on the graph. And then notice at that point our y values are just going to get bigger and bigger. Notice here y is 3, then y is going to be 4. And since this keeps going up, there isn't going to be any highest point, and so we're going to hit everything. And so once again, it's going to be like the other one, except for it will be y is greater than 2. We're basically saying all the points on this graph, the smallest y values is 2, and then we just get bigger and bigger from there on. And we hit everything because this thing goes up forever. There is no highest point. Okay, number 13. Circle each relation that's a function. So on number 13, the question is, does each input have exactly one output? Well, 1 corresponds to 2, and 2 only. 2 has exactly one output. It would be 4. And that's true for all of these, and so this one is a function. Now, number 13 is not. It doesn't pass the vertical line test, and so it's not a function. And so we won't circle that one. And notice on this next one here, we're not going to circle that one because look at the 2. 2 corresponds to 1, and 2 also corresponds to 3. So notice -2 is an input value that has 2 different outputs. These are our inputs, or x values, and these are our outputs, or y values. And so since -2 has 2 different outputs, it's not a function. All right, and all we have to do is find one problem. It doesn't matter that 0, 1, and 3 were okay. If we just find one input that corresponds to 2 outputs, it's not a function. And in fact, if you look at this last one here, I'm not going to circle that one either because look here, we have 3 has 2 different outputs, 5 and 7. And so this is not a function. All right, we have one more problem. It says, what is the domain of the function in this picture? I think the hardest part of this one might be actually writing it down. Anyway, let's see how you did here. So you can see that our x values go from 45 to 23, or that's basically the boundaries of x. And so I'm going to go ahead and put some boundary lines in there. Notice we have solid dots there, so we're going to include those values, 45 and 123. So basically, our boundaries are 45 and 123, and x is between those two values. Basically, we're saying all the points in here have x values between those two numbers. And so you can see that whatever's in here is less than 123, or equal since we have the solid dot. And then what's in here is going to, well, 45 is going to be less than what's in here, so we'll put another less than sign there. Now, a better way, or another way to maybe say this is basically x represents all these x values in here that are between 45 and 123. Our leftmost value on this function is 45, and our rightmost value is 123, and we're hitting every x value in between. All right, and so that's the end of this video.